Welcome friends, welcome back to our YouTube channel Crystal Learning. So today we will solve a question of heat and mass transfer, and this question came in engineering services examination in 2002. So this question says that a vertical pipe of 320 centimeter high having 150 degree centigrade wall temperature is kept in a room with still air at 10 degree centigrade. This pipe supplies heat at a rate of 8 kilowatt in the room by natural convection. Okay, so you have to keep some information given in the question in your mind. That is, it is given that heat transfer is happening by natural convection, and it is saying that assume laminar flow, then tell the height of the pipe needed to supply only 1 kilowatt. Okay, let's draw a diagram for this. So this is the diagram. First, it is saying that the length of the pipe is 320 centimeter. Some hot fluid will be flowing in the pipe. Because of that, temperature will rise of the surface around 150 degree centigrade, and outside temperature is 10 degree centigrade. So definitely that heat will be flow from high temperature to low temperature at a rate of 8 kilowatt. So now it is saying that we don't need 8 kilowatt, we just need 1 kilowatt. Others conditions are remaining same. Okay. So what will be the length of the pipe? So this is the question. Okay, so now to solve this question we have to study some theoretical concept and some formula. So for that, let's study it. So it is saying natural convection. So for natural convection we will need this Newton's law of cooling, which says Q convection is given by H into AS Ts minus T infinity. H is convective heat transfer coefficient, AS is heat transfer surface area, Ts is temperature of the surface, and T infinity is temperature of the fluid sufficiently far from the surface. Okay, so this is the formula. So next we will be would be needing some dimensionless parameters in natural convection effects. So for that, first number is defined Grashof number. Grashof number formula. Right now to solve this question, we just need the formula. How it is coming, we will see in the theoretical lectures. Okay. So Grashof number is given by G beta Ts minus T infinity nu whole square Lc to the power cube. So these are the notation that G denotes gravitational acceleration, beta is coefficient of volume expansion, Ts T infinity you know, Lc is characteristic length of the geometry, will depend on what type of geometry it is given, and K is kinematic viscosity of the fluid. Again another parameter, that is Nusselt number in natural convection, is given by HLC by K, that is equal to C Grashof number into Prandtl number to the power n. Okay, and that Grashof number and Prandtl number product is known as Rayleigh number. So this Rayleigh number is given by this. So you see Nusselt number is given by HLC by K, and in another chapter of unsteady state processes or transient state condition, a number will come, Biot number, giving the same notation, that is HLC by K. So in interview they always ask, maximum time they ask, that what is the difference between Biot number and Nusselt number, because their formula notation is given by same, that is HLC by K. So two basic difference is this LC characteristic length. So in both of the, that is Nusselt number and Biot number, LC will be different. Calculation of LC will be different in both the cases, and this conductivity, thermal conductivity. So what is the difference? That thermal conductivity in Nusselt number is taken for fluid, while in Biot number it applies to the solid. That what is the solid, like solid metal rod. So this is the basic difference. So we won't be going into much detail here, but just keep this question in mind, that what is the difference between Biot number and Nusselt number. So again in the previous formula we have to know the value of constant C and N, and more importantly we have to know the value of N. N will depend on the geometry of the surface, that what is the geometry, and flow regime, that what is the flow, laminar flow or turbulent flow, that will depend on the range given of Rayleigh number. So that is not important, because here in the question it is saying that flow you assume as laminar flow. So N we will be taking as 1 by 4, 1 divided by 4. So this is the Nusselt number formula, that is HLC by K equal to C times Grashof number into Prandtl number to the power n, and we would take as 1 by 4. So all these things are constant for this question, that is K, C, G, B, T, S, T infinity nu and Prandtl number. So here we from this equation we see that HLC is directly proportional to LC to the power 3 by 4. Now LC will come on this side and in division form. So it will be taking 3 by 4 minus of 1 when it will go upside. So it will come 3 minus 4 divided by 4 or minus 1 by 4. So here we got one relation, that is heat transfer, convective heat transfer coefficient is directly proportional to characteristic length to the power minus 1 by 4, and in the given question it is given vertical pipe, and pipe is mostly in form of cylinder. Okay, so cylindrical surface area is given by 2 pi rh or pi d into lc. Lc is the length of the pipe in the given question. So from here we from that Newton's law of cooling, Q convection is given H As into Ts minus T infinity. Ts minus T infinity is constant. So we will remove from here and we will write that Q convection is directly proportional to H into As. H is directly proportional to Lc to the power minus 4, and area is directly proportional to from this relation, because pi and d are constant. So it will directly proportional to Lc. So when this base is same and power will be get added, so minus 1 by 4 plus 1, so it will be minus 1 plus 4 divided by 4 equal to 3 by 4. Okay, so Q convection, this is the important formula we had to derive. So in most of the previous year question, this formula is given directly, so you have to just mug up the question, or you don't understand that how it is coming, because if the question will change, like for it is given for turbulent flow, then this value will change. So you have to remember this. Okay, so what condition they are giving. So for this, so we have arrived here. So now it's easy, we have to just apply this formula and solve this question. So let's come back to the figure, and here it is saying that for first condition 8 kilowatt Q convection is given. Q convection 2, it is second condition, it is saying only 1 kilowatt. For first condition, length of the pipe is 320 centimeter. So we will put in this relation and we will solve further. So here it is given that Q convection upon Q convection 2 second first condition divided by equal to LC2 to power 1, as it is directly proportional. So LC2 to power LC1 condition 1, then LC2 whole to the power 3 by 4, and Q convection is given 8 kilowatt, and this Q convection 2 is 1 kilowatt. So in same unit, no need to change it. Okay, gate also can change the unit also, so in that case you have to pay attention. And here it is given 320 centimeter, LC2 will be coming in centimeter. So this power will go to that side and it will become 8 4 by 3, just opposite 320 by LC2. So this will be becoming like this, that is 8 to the power 4 cube root, and this 8 3 means 4 times, so then 1 8 will come outside and under root cube root 8, and this will be 8 into 2, so 16 divided equal to 320 upon LC2. So LC2 will be 320 divided by 16, so 16 2 and 0 20 centimeter. So length of the pipe will be 20 centimeter. Now you will be needing only 20 centimeter length pipe. I hope you enjoyed this lecture or this question, and the concepts are being clear. So meet you next time. Till then, have a nice day.